All right, so today we are going to do a deep dive into the fascinating world of infrared and visible image fusion. And you've sent us some really interesting research on this topic. And, well, trust me, it's a lot more exciting than it might sound.
Oh, it really is. It's kind of like, like transcending the limits of human sight by merging different kinds of images.
Okay, so let's unpack that a little bit. What exactly are we talking about when we say image fusion? What kind of superpowers are we talking about here?
So imagine being able to see heat signatures,
Yeah.
but also visual details at the same time. So that's basically what image fusion does. It combines images from different sources like infrared and visible light to create this kind of super image that
Yeah.
has way more information than either of the originals.
Got it. So it's not just about like seeing in the dark, it's more about seeing a fuller picture of reality.
Exactly. And the idea is actually not new. It first started back in the 80s,
Yeah.
but it's really exploded in recent years, thanks to artificial intelligence and
Yeah.
particularly deep learning.
Yeah. Deep learning seems to be changing everything these days. But before we get into how it all works, can you give us a sense of why this even matters? Why should our listener care about image fusion?
Well, I mean, it's already impacting our lives in a lot of different ways. Take night vision, for example.
Mm-hmm.
By merging infrared images, which detect heat, with visible light images, we can actually see in the dark, which is really crucial for, military operations, search and rescue, all sorts of stuff.
So is that how night vision goggles work?
That's exactly how they
Yeah,
work.
they're pretty cool.
It is pretty cool, and it actually goes way beyond just night vision. Image fusion is also transforming, things like biometrics,
Hmm.
facial recognition.
Yeah.
Well, image fusion allows those systems to work even in low light. They're not just relying on visual features; they're also using the heat that our faces give off.
Okay, that's pretty amazing. And a little bit creepy too, if you think about it. So
Right.
what else? What other areas are being impacted?
Well, another big one is the medical field. Doctors can now combine different types of scans, like MRI and CT scans, and it gives them a much better understanding of what's happening inside a patient's body.
So it's kind of like it's like X-ray vision, but on a whole other level. You're not just seeing bones, you're seeing tissues and organs, right?
Yeah, it's a great way to put it. And then there's self-driving cars.
Yeah.
Image fusion is a key part of making those vehicles navigate safely, especially in tough conditions like fog or at night.
Yeah, that seems like a pretty tough challenge.
It is. But by combining the data from different sensors, like cameras that see visible light and ones that detect infrared, the car can get a much better sense of its surroundings.
Okay, so you've definitely got me interested, but I have to ask, how does this all work? You keep talking about merging these images, but what are the techniques involved?
Okay, so there are two main approaches to image fusion: spatial domain and transform domain. Spatial domain fusion basically involves working directly with the pixels of the image.
Yeah,
It's kind of like if you were digitally blending two photos together. Okay, so like taking two pictures and kind of carefully merging them to create one image
pretty much.
makes sense. What about transform domain? What is that?
Transformer domain's a little bit more complex. It involves converting the images into a different kind of mathematical representation before you actually combine them.
Okay, I'm going to need you to break that down a little bit.
Sure. So imagine you're trying to combine an image that shows heat signatures with an image that has like sharp details.
Okay, yeah.
Transform domain fusion allows you to separate and manipulate those different aspects so you can enhance the thermal information,
Oh.
but also preserve those, crisp edges and textures. And then you combine them back together. Okay, that's a really good explanation. Sounds like there's some pretty sophisticated math going on behind the scenes. What are some of the specific techniques that are being used within these two domains?
Well, one that's really widely used is called multi-scale transformation. Imagine taking an image and breaking it down into different levels of detail, like zooming in and out.
Okay, I'm picturing like those satellite images where you can zoom all the way down to street level.
Exactly. So multi-scale transformation lets you analyze and combine that information at all those different levels. Maybe combine the coarse thermal patterns from one image with the fine-grained details of another image.
That's really cool. Makes a lot of sense. Are there other techniques that are being used?
Yeah, there's another one called sparse representation. And it's based on this idea that images can be represented using a small number of essential elements. Like,
Yeah.
if you're describing a face, you wouldn't list every single freckle and wrinkle, right?
Yeah.
You'd focus on the main features.
Right, the eyes, the nose, the mouth.
Exactly. So sparse representation lets you reduce the amount of data while still capturing the essential information.
Okay, So it's all about efficiency, right?
Right.
And that makes sense, especially for things like, those self-driving cars we were talking about, where
Yeah.
speed is so important.
Yeah, absolutely. And then there's also compressed sensing, which is
Right.
all about efficiency as well. Imagine you're trying to send a secret message. You wouldn't just write it out in plain language.
Yeah.
You'd want to use a code to compress it and make it hard to decipher.
Right. So you're packing the most important information into a smaller package.
Exactly. And that's really valuable for image fusion
Mm.
because it lets us transmit and process images more efficiently, which is super important for real-time applications.
Okay, so this is all incredibly fascinating. It feels like we've only scratched the surface.
Yeah, we've really just begun. And in the next segment, we're going to delve into the real star of the show, deep learning.
Ooh, I can't wait to hear more about that. How deep learning is taking all of this to the next level.
Yeah, so deep learning is it's really kind of changing the game when it comes to image fusion.
Okay, so remind me again, how is deep learning actually being used in image fusion? What makes it so special?
So deep learning algorithms,
Yeah.
particularly a type called convolutional neural networks.
CNNs?
Yes, CNNs. They are really, really good at learning patterns from massive amounts of data.
Okay.
And in the case of image fusion, we can train a CNN on huge data sets of paired images.
Paired images meaning like an infrared image and a visible light image of the same scene.
Exactly. So by analyzing these pairs, the CNN learns to extract the most relevant features from each source and then fuse them together in a way that preserves the key details.
So it's almost like you're teaching the computer to be like a master image fusion artist.
Yeah, that's a good way to put it.
Well, without having to like program all those instructions manually.
Exactly. And the results are often really amazing. Like deep learning algorithms can achieve levels of detail and accuracy that just weren't possible before.
That's really incredible. So we've talked a lot about the technical side of image fusion, but I'm curious to hear more about the actual applications. We've touched on a few already. But let's dive deeper. Like, where are we seeing the biggest impact of this technology right now?
I think one area where it's having a huge impact is medical imaging. By combining different types of scans, doctors can get a much more complete and accurate picture of what's happening inside a patient's body.
Yeah. So it's not just about seeing things more clearly. It's also about getting a deeper understanding of like the underlying structures and processes. Right?
Absolutely.
Yeah.
Image fusion is helping doctors to diagnose diseases earlier,
Mm-hmm.
plan treatments more effectively, monitor patient progress more accurately. It's really transforming healthcare in a lot of ways.
That's amazing. What other areas are being impacted?
Another big one is autonomous vehicles.
Self-driving cars are definitely one of those things that feel like
Yeah.
they're straight out of science fiction. What role does image fusion play in making them a reality?
Oh, it's huge. I mean, imagine a self-driving car navigating a busy street. It needs to be able to see everything around it, even in conditions like fog or heavy rain.
Yeah, I mean, that seems like a pretty tall order.
It is. And that's where image fusion comes in. By fusing data from multiple sensors, like cameras that see visible light and ones that detect infrared, the car can build a much more complete picture of its surroundings.
So it's kind of like giving the car a sixth sense.
You could say that.
Oh, God.
It's not just about seeing what's directly in front of it. It's also about anticipating potential hazards and making split-second decisions
Yeah.
based on a much richer set of data.
Okay, that's amazing. Are there any other applications that are worth highlighting?
Yeah, another interesting one is in surveillance and security. Image fusion is being used to enhance the capabilities of surveillance systems, allowing them to operate better in low-light conditions or in areas with a lot of visual clutter.
So it's almost like you're giving these security cameras superhuman vision.
Yeah, kind of.
Like they can see through the darkness and pick out things that a human eye would never be able to see.
That's right.
Wow.
And that obviously has big implications for
Yeah.
crime prevention, border security, all sorts of things.
Yeah, it's amazing how versatile this technology is. I mean, we've talked about medical imaging, self-driving cars, surveillance, and that's not even mentioning all the other areas where it's being used.
Yeah, it really is a game changer. And the potential applications are just beginning to be explored.
Okay, so this is all incredibly exciting, but I also have to wonder, are there any limitations to this technology? Like, what are some of the challenges that researchers are still working to overcome?
Well, one of the big ones is just ensuring the accuracy and reliability of the fused images. When you're combining data from different sources, there's always the potential for errors or inconsistencies.
Yeah, so it's not just about merging the images, it's about making sure that the merged image is a true and accurate representation of reality.
Exactly. And researchers are working on developing more sophisticated algorithms
Yeah.
to improve the quality and reliability of those fused images.
Okay, are there any other hurdles?
Yeah. Another challenge is the computational complexity of some of these algorithms. Image fusion can involve processing huge amounts of data,
Mm-hmm.
which can be very computationally expensive.
So it's not just about coming up with the right algorithms, it's also about making sure that they can run efficiently on, real-world hardware.
Yeah, that's a key consideration, and it's especially important for things like self-driving cars,
Mm.
where speed and efficiency are so critical.
Right, that makes sense. So it sounds like there's still a lot of active research and development happening in this field. Where do you see things going in the future? What are you most excited about?
Well, I'm particularly excited about the use of deep learning to further enhance the capabilities of image fusion. As those algorithms continue to improve, we'll be able to create even more sophisticated and accurate fused images.
So it's almost like we're giving the computers even better tools to understand and interpret the world around them.
Yeah, exactly.
Wow.
And as the technology continues to evolve, I think we're going to see a whole new wave of applications emerge.
It's mind-boggling to think about all the possibilities.
Yeah.
All right, well, I'm ready to hear about some of these exciting new frontiers. Okay, so we've talked about how image fusion works. We've explored some of the current applications, and we even touched on some of the challenges. But now I'm really curious about the future. Like, where do you see this technology going? What are some of the emerging areas where image fusion could have a big impact?
Well, one area that I find particularly intriguing is agriculture. Imagine using drones equipped with infrared and visible light cameras to monitor crops.
Oh, wow. So instead of just relying on what the human eye can see, farmers could get a much more detailed understanding of the health of their crops.
Exactly. Infrared cameras can detect things like plant stress, water deficiencies,
Hmm.
even early signs of disease that might not be visible to us.
So it's like giving farmers this superpower to see their crops in a whole new way.
Yeah, and by fusing that information with visible light images, farmers could make much more informed decisions about things like irrigation and fertilization.
Well, that's a really cool example. What other areas are ripe for innovation?
Another one with huge potential is environmental monitoring. Imagine using image fusion to track deforestation, monitor wildlife populations, even assess the health of coral reefs.
So we could use this technology to really get a much clearer picture of the impact of things like climate change.
Exactly. It could be an invaluable tool for scientists and conservationists.
Okay, that's really powerful. It's exciting to think about how this could be used to address some of the biggest challenges facing our planet. Are there any other areas you're particularly excited about?
The one that I think holds a lot of promise is archaeology. Infrared imaging can sometimes reveal buried structures or artifacts that aren't visible on the surface.
Oh, wow. So
Well,
it's like having X-ray vision for the Earth itself.
You could say that. By fusing infrared images with other types of data, like aerial photos or ground-penetrating radar, archaeologists could get a much more complete picture of what lies beneath.
This has been incredibly fascinating. It really feels like image fusion is one of those technologies that has the potential to change the world in really profound ways. But before we wrap up, I have one final question for you. What's one thing you'd like our listener to take away from this deep dive? What's the biggest aha moment you hope they've had?
I think the biggest takeaway is that image fusion isn't just about creating, cool pictures. It's about expanding our perception and understanding of the world. By merging these different types of images, we can literally see things that were previously invisible to us. And that has the potential to revolutionize so many fields.
That's a great point. It's not just about seeing more, it's about understanding more. And it's a good reminder that there's so much more to the world than meets the eye. Even the most powerful camera can only see so much. But if we learn to combine different perspectives and see the world through new lenses, who knows what incredible discoveries we might make? Well, that's something for you to ponder, listener. As you continue exploring this amazing field, we encourage you to dig deeper into the source material that you shared with us. And as always, feel free to reach out if you have any questions.
Absolutely.
We're always up for another deep dive. Thanks for joining us on this journey into the unseen. Until next time, keep exploring.